Hi everybody, and welcome to the video for task 6.9. Today's learning target is going to be to graph the solution to a system of linear inequalities when the inequalities are written in standard form. So we're actually going to go ahead and skip the first page of the notes that we're going to do together. We're going to jump into the second page of these notes, and that's where we're going to start. The idea for today is that we're going to have a system of linear inequalities. When you have a system, that means you're going to have two inequalities at the same time. So for example, in this problem, we have two inequalities and we're trying to solve this system, which means identify points that work for both of these at the same time. Now, the first inequality that we're going to work on here is going to be 2x minus 6y is greater than or equal to negative 12. So what I'm going to do is sort of graph these one at a time. If we start with this first inequality, because this inequality is in standard form, we're going to start making this graph by finding the X-intercept, which is the place where y is 0, and by finding the Y-intercept, which is the place where x is 0. So let's go ahead and calculate those things. If we want to figure out the X-intercept, we basically sort of ignore the term of the equation that has a y in it. So we would have 2x equals negative 12. If I solve this equation, I would divide by 2 on both sides, and that's going to give me x equals negative 6. So my X-intercept would be negative 6, 0. Now my Y-intercept, I'm going to ignore the term that has an x. So I would have negative 6y equals negative 12. And I would divide by negative 6 on both sides. And that's going to give me y equals 2. So my Y-intercept would be 0, 2. Now, after I do that, I'm going to go ahead and add those 2 points to my graph. So negative 6, 0 would go right here, and 0, 2 would go right here. Now remember, because this problem does not have an equals sign, it has a greater than or equal to, we still have a couple more decisions to make. We need to decide if this line should be solid or dashed. Because of the little underline, which means we do want the numbers that are equal, we're going to make this a solid line. So I'm going to go ahead and draw a solid line that goes through those 2 points. Next, we need to decide where to shade. Now, when we have an equation that's in standard form, we decide where to shade by testing 0, 0. Now on this graph, 0, 0 is right here. So if we end up with an answer that is true when we plug in the point 0, 0, we're going to shade the side of the line that has that point. If we end up with an answer that is false, we're going to shade the other side. If I plug in 0 and 0, I get 2 times 0 minus 6 times 0 is greater than or equal to negative 12. This part of the problem simplifies to just 0. And since 0 really is bigger than negative 12, this is true. That means that on this graph, I would now shade the side of the graph that has the point 0, 0. So it would be this side of the line that I'm going to shade. Now, if you're doing this with pencil on your paper, you're going to want to shade very lightly because the next thing that we're going to do is graph another line. So let's go ahead and look at the second equation that we were given here. We were given the equation 3x plus 3y is greater than negative 6. Now, for that equation, we're going to follow the same process. So we're going to find the X-intercept, which is the place where y is 0. We're going to find the Y-intercept, which is the place where x is 0. And then we're going to test 0, 0 to see if that point is a solution or not. So if I test, or if I find the x-intercept, I'm going to ignore the y. So I'm going to have 3x equals negative 6. If I divide by 3, I get x equals negative 2. And that's going to give me the point negative 2, comma 0. If I'm finding the y-intercept, I'm going to ignore the part of the equation that has the x. So I'm going to have 3y equals negative 6. I'm going to go ahead and divide by 3 on both sides, and I'm going to get y equals negative 2 again, but this time it's the point 0, comma negative 2. So if I add those 2 points to my graph, negative 2, comma 0, 0, comma negative 2. Now, just like before, I'm not drawing my line right away. I'm going to go ahead and take a second and think, is this a solid or a dashed line? Because there is no underline under the symbol here, this is going to be a dashed line on the graph because we don't want the points that are exactly equal to negative 6. So if I go ahead and draw a dashed line here, it's going to look like this. And it goes right over the top of that other stuff. I'm going to kind of ignore it, pretend it's not there, that blue shading and the blue line. Next, I'm going to test the point 0, 0 to see if that works. So if I test 0, 0, I get 3 times 0 plus 3 times 0 is greater than negative 6. That means I get 0 is greater than negative 6. Now in this case, 0 really is bigger than negative 6. That's true. So once again, I want to shade the side of that green line that has the point 0, 0. Well, the side of the green line that has the point 0, 0 would be this side. So you'll notice I'm shading, I'm going right over the top of my blue shading. Now the goal today is to find a section of this graph that works where we shaded for both lines. We know that when we shade the blue part and when we shade the green part, we're representing all of the solutions. If we want to find solutions that work for both, we need to look for where those lines overlap. Now, the part of this graph where those shaded parts overlap would be right over here. So if I shade the part where they overlap, and you'll notice I'm making it darker, so you should have shaded very lightly for the other two shadings. We're going to make this darker. This area of the graph is going to be the solution area. What that means is any point you choose from this area is going to be a solution for both of the original inequalities that we had. And that is our goal when we're solving a system, is find the area that works for both of these graphs. Let's go ahead and scroll down. We're going to basically just write down the steps so that you have them written out, and then we're going to do one more example and a word problem. So step number 1, whenever you have a problem where there's two inequalities, is to graph inequality number 1 and then test the point 0, 0 in order to shade. Step number 2 is graph inequality number 2, and then test a point to shade. Finally, look for the intersection of the two shaded regions. In this graph, you can see that the intersection, the darker region, would be right here. This would be my solution region. Any of the points that are in that region are all going to be solutions to the inequality. So if I ever say, hey, state a solution, find me a point that works, you can pick any point from this section. For example, I could pick the point 1, 2. Or another example would be I could pick the point 3, 3. Any points from inside that overlapping shaded area would be solutions to the system. Let's try another example so you can see it one more time. If you want to solve this system, that means you have to graph these both separately and look for where the shaded parts of the graph overlap each other. So if I graph this first line, what I'm going to start by doing is I'm going to find the x and the y-intercept. The X-intercept is the place where y is 0, and the Y-intercept is the place where x is 0. Now my X-intercept here, I would have the equation 2x equals 4. When I divide by 2 on both sides, I would get x equals 2, so my starting point would be 2, 0. My X-intercept. And for my Y-intercept, I would just have y equals 4, so my Y-intercept would be 0, 4. I'm going to go ahead and add those to my graph. So 2, 0, 0, 4. Step 2 is decide if this should be a solid or a dotted line. Because of the fact that there's a little underline, we're going to make this a solid line because we're including the points that are along that line. So when I graph this line, I'm going to go ahead and draw a nice solid line through those points. Next, I'm going to go ahead and decide where to shade. So let's test the point 0, 0. Again, you can test any point. Technically, I like to test 0, 0 because it's super easy to plug in. If I plug in 0, 0, I get 2 times 0 plus 0 greater than or equal to 4. So I have 0 greater than or equal to 4. Well, 0 is not bigger than or equal to 4, so this is false. That means I'm going to shade the other side of the line. So I'm going to shade this side over here. If you're using a pencil, you're going to do that very lightly because remember, the ultimate goal is to look for these shaded regions we're finding overlap. And so you don't want to make this one too dark. You want to be able to see where they overlap. Next, let's go ahead and graph the line 3x minus 2y is less than 6. So if I take this equation, if I find the x-intercept, that's going to be the place where y is 0. And that's going to give me 3x equals 6. And if I divide by 3, I get that x is equal to 2. So my x-intercept is going to be 2, 0. It's going to be right here, right on top of the other x-intercept that I already had. My y-intercept is going to be the place where x is 0. And that means I'm going to have negative 2y equals 6. If I divide by negative 2, I get y equals negative 3. So that's going to be 0, negative 3 right down here. Next, I'm going to decide should this be a solid or a dashed line. Because there's no underline, we don't want the points that are exactly equal and on the line, so we're going to make it dashed. And that means my line's going to look like this. Last but not least, I'm going to go ahead and shade. In order to decide where to shade, I'm going to test the point 0, 0. So if I test 0, 0, I get 3 times 0 minus 2 times 0 is less than 6. 0 is less than 6. Well, that's actually true. So I want to go ahead and shade the side of the line that has the point 0, 0 this time. In this graph, the side of the line that actually has the point 0, 0 would be this side of the line over here. And if I keep going until I shade all of it, you can see where that color kind of overlaps because it changes to purple, right? Pink and blue make purple. So our solution region, the region that has all the solutions that would work for both inequalities, would be this purple region of the graph right here. You'll notice that I'm making it darker. On your paper, you should shade that a little bit heavier to show that that's where the two regions overlapped. The last thing we're going to do today is go ahead and talk about a word problem. So it says here, it's time for the end of season team celebration. Players each get 2 servings of whatever they're having, maybe pizza or pasta, and guests get 1 serving. You can order 20 servings at most, and you need to feed at least 12 people. How many players and how many guests can you feed? The first thing I'm going to do is I'm going to look at the question. How many players and how many guests can I feed? That's going to help me figure out what my variables should represent. Since I'm trying to figure out the number of players and the number of guests I can feed, I'm going to make x equal to the number of players. And I'm going to make y equal to the number of guests. Now I'm going to make a system of inequalities. So I'm going to write 2 problems here. The first problem, I'm going to base the inequality that I write on the fact that I can order 20 servings at most. So let's think about the servings here. I know that every player is going to get 2 servings, and I know that every guest is going to get 1 serving. So that means 2x, because x is the number of players, plus 1y, because y is the number of guests, needs to be at most, and at most means that's the biggest I can go, so less than or equal to 20 total servings. Now, my next inequality that I'm going to write is going to be based on this piece of information. I need to feed at least 12 people. Well, if I look at how many people, I can figure out that number by adding up how many players and how many guests are there. So x plus y has to be at least, which means more than or equal to 12 people. So let's go ahead and graph our system. The first thing I'm going to do is I'm going to figure out the x-intercept and the y-intercept for this first inequality. So the x-intercept, which is the place where y is equal to 0, is going to be 2x equals 20, and then I'm going to solve that. I'm going to divide by 2, and I'm going to get x equals 10, so I'm going to have 10, 0. My y-intercept, which is the place where x is 0, I'm going to solve that equation, which is 1y equals to 20. Well, since 1y is the same thing as just y, I can already kind of know the answer. Y is 20, so 0, 20. If I go ahead and add those to the graph, so 10, 0 is right here, and 0, 20 is right here. Now I'm going to decide if this should be a solid line or a dotted line. Because of the fact that there's a little underline and we want to be potentially equal to 20, I'm going to make it a solid line. So if I go ahead and graph this, I'm going to use a solid line to do that. So my graph is going to look like this. Now, there's a couple things about graphing when it's a story problem. One of the things, and I didn't do a very good job of showing this, I apologize, is that your graph should really stop at the axes. It doesn't make sense to have a negative number of people or a negative number of players at this party. So we want to make sure we actually stop at the x and the y axis. There's no arrows, the line doesn't keep going. The next thing we need to decide is where to shade. So we're going to go ahead and test the point 0, 0. If we test the point 0, 0, we get 2 times 0 plus 1 times 0 is less than or equal to 20. So 0 is less than or equal to 20. Well, 0 actually is less than or equal to 20. So since this is true, I'm going to go ahead and shade the side that has 0, 0. Now again, just like the line stopped on the x and y axis, the shading is going to stop also. So I'm only going to shade this corner. You'll notice I'm not going into the negatives. Next, let's work on the second line that we have here. So we are going to find the x-intercept, which is the place where y is 0. The x-intercept would just be x equals 12. So we would have the point 12, 0. To find the y-intercept, which is the place where x is equal to 0, we would have y equals 12. So we would have 0, 12. Now, if I go ahead and graph that line, I'm going to go ahead and draw, and I'm going to again stop at the x and the y axis. And now I need to figure out where to shade. So if I test the point 0, 0, I get 0 plus 0 is greater than or equal to 12. So I get 0 is greater than or equal to 12, which is actually false, which means I want to shade the side of this line that does not have 0, 0. So that would be this side up here. Now, where do those two solution regions intersect? Where do we find where they overlap? The overlapping part would be this little corner of the graph right here. And that's my solution region. So, if I want to name some possible combinations of players and guests I can feed, I'm going to pick any of the points within this region, and those are going to be solutions. An example might be 1 player and 15 guests. Now, the last thing I'm going to do before I'm officially done with this problem is I'm going to label the axes. It's really important in these graphs to make sure you label your axes. And just to make sure you don't forget, I will always put that in the instructions as well. Since X represents the number of players in this problem, we would label that this is the number of players. And since Y represents the number of guests, we would label that this is the number of guests. All right, I hope that this made sense, that the idea today is we're just graphing two inequalities on the same graph, and we're finding where their shaded regions overlap to see where the solution of the system would be. I'm going to go ahead and have you guys work on the Ready, Set, Go practice problems for the rest of class, and I'll see you soon for some questions. Thank you.